Now, I have spent quite a lot of time studying imaginary numbers and complex numbers. And this isn't going to be a full video on imaginary and complex numbers. It's just not. I don't have the time right now. But I did want to show you guys something cool that I learned. Now, as we know, imaginary numbers are of the form n and I. Okay, and this is where n is the real number and it's being multiplied to the imaginary unit I, such that I is defined by the equation I squared equals -1. Moreover, the entire reason that imaginary numbers were established in the first place, to my understanding, is because we couldn't take the square root of negative numbers. And that's not cool. So there was a system that was created that allows us to take the square root of negative numbers. Thus, the imaginary unit I equals the square root of -1. So there's something called cyclic numbers, and cyclic numbers is a number, it's like numbers that cycle. So example, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. That's a cyclic sequence, right? Because it's a it's repeating itself, it cycles, all right? So there's an interesting cyclic property that occurs when I is being raised to various powers. Written before you is I being raised to various powers. We have I raised to the power of 0 is 1, I being raised to the power of 1 is I, and we know that I is equal to the square root of -1. We have I raised to the second power, it's equal to -1. I raised to the third power is equal to -I, and it's sort of this is where the cyclical nature of the relationship between I being raised to the various powers stops and resets. So if you go 1, 2, 3, 4, such is true across this entire sequence, because if you look at this in the with brackets, all of these are the same, right? I raised to this to the power of 0, it's 1. I raised to the power of 4 is 1. I raised to the power of 8 is 1, and it's going to continue throughout. Okay. Likewise, I raised to the first is I raised to the fifth is I raised to the ninth is I raised to the second is -1. I raised to the sixth is -1. I raised to the 10th is -1. And finally, I raised to the third is -I. I raised to the seventh is -I. I raised it to the 11th is -I. Cool. So here is where I started having problems. Because I'm like, how can I find I raised to the 63rd power? Well, the way that my brain thought about this, I was like, well, okay, I can literally I can continue the sequence of raising I to the various powers up to I to the 63rd power following this trend. In other words, I could write I up to the 63rd power following this rule that we've learned here, but there has to be an easier way to do it. Like, I shouldn't have to write out all of the different powers of I up to 63 in order to determine what I to the 63rd power is. There has to be an easy way. So I go to my calculus professor, and his name is Professor Michael Farquhar, and I'm like, sir, how do I determine if I is brought up to the 63rd power? How do I determine that? And he didn't say it exactly like this, but he basically said, so do you see how the numbers of I are cyclical by 4, and they change in 4s and then repeat? And he said, well, you have to take 63, because that's what the power is being raised to, and you have to divide it by 4. And then, just right off the bat, he says that the answer is going to be 15 and 3/4. And he just did that in his head. Now, I cannot do that in my head. So what I'll do is I will do long division. Okay, 15 remainder 3, 15 3/4. So he goes, all right, now so look at the remainder here. Look at this 3. There's 3/4, so look at this 3. Now, when I is raised to the power of 3, when I is raised to the power of 3, you get -I. So I raised to the 63rd power, well, it's going to be -I. Then he tells me, this here, it's called modular arithmetic. He says this is a branch of math called modular arithmetic. And I'm like, that is so cool. So that's how you do that. And yeah. Side note, this had nothing to do with the class that I'm taking. He's just a cool professor that likes math, and he helped me understand this. Anyway, shout out Professor Farquhar, and I'm going to do more math now, off camera.